Mhm. Okay.
Hey everyone, and welcome back to the channel. For those of you who are new here, my name is Jordan. I'm a Google software engineer, and in today's video, I will be beginning my refactored systems design interview series. So I am absolutely a hypocrite for this, in the sense that I said I didn't want to make redundant content on the channel, but at the same time, one of the biggest pieces of feedback that I received in my last series was that even though the content was very rich, I often didn't give a lot of visual aid. And trust me, I understand that visual aid is very important. For example, try, doing your thing without hub or something, it would be real tough. So with all these things in mind, I've acquired an iPad. I don't really know how to use it very well. My drawing skills are very bad and my hands are shaky. But, worst comes to worst, the iPad is going to make certain parts of my life a lot easier. And my ultimate goal is to make content on this channel that is pretty much as good as all those paid courses from these grifting tech YouTubers, with the exception that it is completely free. In fact, I hope to make it better because, I'm just going to try and do a really, really thorough deep dive on everything. And unlike my last series that I kind of made, I'm hoping to even do smaller chunks per video for a couple of reasons. One is that it's more digestible, and the other reason is that I'm a lazy fuck and I don't like editing that much. And so I figure that, it's a win-win for the both of us if this series takes a little bit longer by doing less per video. So with that all being said, if you're new here or if you're new to systems design in general, I think this series will be super useful for you. It really does cover a lot, so expect to learn a lot. And this is a great time to start learning because the economy is in a downturn at the moment, but in 6 months to a year, when this series is finished, jobs are probably going to be pretty hot again, and you're going to want to get a refresh on that RSU price. So all those things being considered, let's jump into it. We can go ahead and do a little example of what systems design kind of means or is, or the considerations that you might have on the iPad, and I will do my best to make it understandable for all of you. Have a happy new year, and let's get into it. All right, let's go ahead and get into this. So to kind of frame the systems design interview as a problem, it's basically something like this. You're a website, you are perhaps even just an internal infrastructural service with a lot of usage, right? So much so to the point that just storing everything on one machine is not sufficient anymore. And so let's give an example of that. So here I am drawing myself on screen. As you can see, I've drawn myself to figure, absolutely jacked and muscular. So this is me. And in the context of a website like a social media website, let's say Facebook for example, I am what is known as the client. I make requests to the servers of the social media website, and in exchange I expect data. So let's go ahead and show that trade-off. Here I am drawing a nice little arrow, and then if we're talking about Facebook for example, here is the Facebook application server, which will probably be located in one of their data centers. So now what I'm asking for from Facebook is some data. At some point, I probably stored something like a profile picture there, I stored some information about myself or my past posts, and I want to get it back from them. If Facebook didn't store this data in the first place, how could they possibly leak it? So here we go, and we have these Facebook servers. And so the question is now, kind of one of the ways that I want to start thinking about these problems is where do we
Mhm.
actually store the data. So before we even think of, what servers we store the data on, let's think about what hardware we store the data on. So when it comes to data in general and computers, there are two basic places that you can put it, and one is RAM. It looks like a little long rectangular skinny dick chip, and that is good for random access, or basically it's short for random access memory, but it's good for temporary storage of data. That's where we do our computations when we're coding. If you're writing like a for loop, you're adding a couple numbers. Technically, a lot of that's going on in CPU registers, but eventually it's going to get stored with the variables in RAM. And in addition to that, we have our HDD, or our hard drive. And so this is, I'm sure you've seen this before, looks almost like an iPad, but with a nice little skinny metal disc in the middle, and then this kind of pointer which points to a specific part of the disc. Again, pardon my bad drawing skills. And the good thing about hard drives is that can actually permanently store data, at least in the sense that the hard drive itself is not broken or other extenuating circumstances. So when we are actually going to store data for a company like Facebook, we want to obviously put that on the hard drive. Why? Because servers can shut down at any given time. Maybe someone unplugs the power, and if that were to happen, we don't want to lose the data. Of course, hard drives can be broken too, and we have to think about more than that, but at least for now, let's just think we're storing our data on this hard drive. And that's going to be a little bit slower than RAM, but we'll touch upon this in future episodes. This is mainly just for an introduction. So the next question is, what computer do we actually put this data on? Every computer is a hard drive, but which computer is the one actually holding the data? Should it be the Facebook application server? Well, actually, the answer is probably not. And why is this? Well, for starters, the Facebook application server is not just talking to me. It's talking to a bunch of other people, right? Here are all these other betas throughout the world. Even though I'm the alpha, unfortunately, I have to contact the same servers as them. And so eventually there are going to be so many people that just one application server to talk to all these people isn't going to be enough. I'm actually going to need more. And so, we've got all these other servers, and if we were to actually store, my specific profile data on the original server, now that's going to be a problem, because when these guys go ahead and contact other servers, they're not actually going to be able to see their data, they're not going to have access to it. And so in this sense, we want our data itself to be scalable in a way that is separate from our application servers. The application servers, or at least the user requests to application servers, typically becomes a bottleneck to the performance of our website before the actual accessing of the data does. Typically that's because there's things like caching, where we can temporarily store some of the data on these servers, and that makes things easier, but again, this is all stuff we're going to get into later. So what we really want to be doing instead is basically having one other computer in the background. You'll see I'll draw it as this cylinder here, and this is what I'll call a database. The database is only responsible for being basically the sole source of truth of all of that profile data, post history, all of these things, and now application servers can go ahead and just ask the database for specific data about profiles, my users, all my Facebook history, etc., etc., etc. This is completely oversimplified, right? The truth of the matter is, when you have so many users, even one database isn't going to be enough, right? We can make the computer that the database is located on more powerful, but eventually, even that's not good enough. There's simply just too many humans in the world. And so the main kind of point of systems design is, how can we make the fetching